Sorry that I could not make it to class today. I am at Apple training, as I'm sure you all know. Please make sure you behave. I expect to get a note to see how you guys did today. I expect to see a note that you guys performed well, did your job, there was not a problem at all. I'm going to do my best to go over these concepts, which we hopefully would have gone over some of them prior to this class, so a lot of it will be review, especially on this particular one. Let's start number 22. We're talking about more functions, graphing with a table and graphing with intercepts. That might be the only new thing we'll talk about today. X-intercept. We're going to talk about the x-intercept and the y-intercept. One of the keys is that the x-intercept means that y is 0, and the y-intercept means that x equals 0. But for now, we're talking about a bit of a review. Question number 1 says, which of the following relations are functions? So let's determine which of them are functions. Is A a function? Well, this has one output, that has one output, that has one. Each one of these have one output. So I would say yes, and the reason why is each input has one output. Let's look at B. Is B a function? That has one, that has one. But even though it doesn't look like it because they're all going to the same guy, the answer is yes. Again, each input has one output. That has one, that has one, that has one. They all have one. C, is this one a function? The answer is no. This one has one, this one has one, this one has one, this one has one, but this one has two. So 1 has two outputs because 1 goes to 0 and 1 goes to 15. That would be 1 comma 0 and 1 comma 15, which is not okay. That x value is hanging out with two different y's. Is D a function? The answer is, it looks tricky. You might not have seen this guy. The answer is no, because 16 has no output. In order to be a function, each input has to have exactly one output. That has one, 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 that has 0. Each one has to have exactly one. Now the next thing I sort of asked you to do was I asked you to, for A and B only, write the following as ordered pairs. Let me quickly write them as ordered pairs. I sort of did it with C. This would be -3, comma 3. Then it would be -2, comma -6, -1, comma 0, 0, comma 15, and 1, comma -1. As you can see, each of the x's are different, so it is a function. This is -3, comma 6. This one's -2, comma 6. This one's -1, comma 6. This one's 0, comma 6. And the last one is 1, comma 6. So they all go to 6. So I wrote them all as ordered pairs. The daily quiz sort of goes through an entire type of question you might have to do, but I sort of scaffolded it, made it easy for you to do. So I'm going to take this equation with two variables, 3y minus 6x equals 12, and write so y is a function of x. If you didn't remember what that means, here's a clue. Y equals. Solving for y. 3y minus 6x equals 12. First, isolate the term that contains my variable, plus 6x plus 6x. 3y equals 6x plus 12. Send the constant to the end, send the constant to the end, send the constant to the end. Divide every term by 3. Y equals 2x plus 4, which is the exact same equation we use over here. It says to complete the table. I'm going to complete the table by plugging my x's. I started off for you. If x is 2, instead of x, I'm going to put 2. If x is 1, I'm going to put 1. Then 2 times 0 plus 4. Then 2 times -1 plus 4. Then 2 times -2 plus 4. Then I'll do my order of operations. 2 times 2 is 4. 4 plus 4 is 8. 2 times 1 is 2. 2 plus 4 is 6. 2 times 0, that's the multiplicative property of 0. That's 0 plus 4 is 4. Should be noticing a pattern. 2 times -1 is -2 plus 4. They fight. The positive win by 2. 2 times -2 plus 4, which is -4 plus 4. They fight. They're called additive inverses of 0. So now I'm going to use this information to graph on the coordinate grid. Now I'll take this information and graph it. If x is 2, y is 8. Well, I probably should label x and y 1, 2, 3, 4. This is positive 5, 2, 3, 4, This is positive 5, 1, 2, 3, 4. This is negative 5, 1, 2, 3, 4. This is negative 5. All right, let's graph them. 2, comma 8, 2, 5, 6, 7, 8. 1, comma 6, 0, comma 4. You put 0, 4 there, it doesn't really make sense. If you notice there's, again, a visual pattern now, negative 1 up 2, and to the left 2 up down to 0. So it's not just these 5 points. We're graphing this line like that. All right, a bit of a get-ahead question. We talked about this. What is the x-intercept and what is the y-intercept? The x-intercept is simply where it crosses the x-axis. So if I highlight again, let me highlight in the proper colors. Let's do this in blue. I'll do the x-intercept. So in order to get my x-intercept is where it crosses the x-axis, which is right there. My x-intercept is negative 2, comma 0. So left 2, up, down 0. Now let's do the y-intercept. I'll do this in orange. The y-intercept is where it crosses right here. Sorry, y-intercept in orange. So across the y-axis, which is left, right, 0, up, 1, 2, 3, 4. That's my y-intercept. Now if you notice, the y-intercept, x was 0. On the x-intercept, y was 0. That is not a coincidence. We'll use that today. All of the x-intercepts, y will be equal to 0. All of the x-intercepts, y will be equal to 0. And all of the y-intercepts, x will be equal to 0.